MES College Marampally, e-learning.
I am Arija Rajiv, Assistant Professor, Department of Mathematics and Statistics, MES College Marampally. Today, I am going to deal with some basic concepts of regression analysis, which is a part of almost all complementary statistics courses. Let's start with the definition of regression analysis. Regression means moving back, stepping back or returning to the average value. It was first used by Sir Francis Galton. It is a statistical device used to study the relationship between two or more variables that are related. So, regression means the estimation or prediction of the unknown value of one variable from the known value of the other variable. So, we can define regression analysis, that is, regression analysis is a mathematical measure of the average relationship between two or more variables in terms of the original units of the data. In regression analysis, we have two variables, that is dependent and independent variables. The variable whose value is influenced or is to be predicted is called dependent variable. The variable which influences the values or is used for prediction is called independent variable. For example, a company wants to know if there is significant relationship between its advertising expenditures and sales volume. Here, independent variable is equal to advertising expenditures, dependent variable is equal to sales volume. So, next, utility of regression analysis. It helps in establishing a functional relationship between two or more variables. It is a valuable tool for solving many problems of economic and business research. It can be used for prediction or estimation of future production, price, sales, income, profits, etc. This technique is highly used in our day-to-day life and sociological studies, as well as to estimate the various factors such as birth rate, death rate, yield rate, etc. It provides a formidable tool of statistical analysis. Types of regression analysis. 4 types of regression analysis are there: simple and multiple regression, linear and non-linear regression. So, first we discuss about simple and multiple regression. The regression analysis confined to the study of only two variables at a time is termed as simple regression. Example, influence of advertisement on sales. The regression analysis for studying more than two variables at a time is known as multiple regression. Example, yield of a crop depends on rainfall and fertilizers. Next is linear and non-linear regression. If the given bivariate data is plotted on a graph, the points so obtained on the scatter diagram will more or less concentrate around a curve called curve of regression. If the regression curve is a straight line, we say there is linear regression between the variables under study. In a linear regression, the change in the dependent variable is proportionate to the change in the independent variable. If the curve of regression is not a straight line, then the regression is termed as curved or non-linear regression. In this case, the dependent variable does not change by constant amount of change in the independent variable. Next, regression lines. A regression line is a graphic technique to show the functional relationship between the dependent and independent variables. When the given bivariate data are plotted on a graph, we get the scatter diagram. If the points in the scatter diagram concentrate around a straight line, that line is called line of best fit. The line of best fit is that line which is closer to the points of the scatter diagram. This line is also known as regression line. Two regression lines are there, namely regression equation of y on x and regression equation of x on y. First one is the line of regression of y on x, which is the line which gives the best estimate of y for any given value of x. Second, the line of regression of x on y, which is the line which gives the best estimate of x for any given value of y. Regression equations are the equations of regression lines. It is a mathematical relation between dependent and independent variables. So there are two regression lines and hence two regression equations. Regression equation of x on y, regression equation of y on x. Regression equation of x on y. So if we have to estimate the value of x for a given value of y, we use the regression equation of x on y. The equation of regression line of x on y is x minus x bar is equal to bxy into y minus y bar, where bxy is regression coefficient of x on y. Regression coefficient of x on y, some formulas are given here. Bxy is equal to r into sigma x by sigma y, or bxy is equal to n into summation xy minus summation x into summation y divided by n into summation y square minus summation y the whole square. Or we can use another formula for bxy, which is equal to n into summation dx dy minus summation dx into summation dy divided by n into summation dy square minus summation dy the whole square. Next is regression equation of y on x. Here we have to estimate the value of y for a given value of x. We use regression equation of y on x. The equation of regression line of y on x is y minus y bar is equal to byx into x minus x bar, where byx equal regression coefficient of y on x. First one, byx equal to r into sigma y by sigma x, or byx equal to n into sigma xy minus sigma x into sigma y divided by n into sigma x square minus sigma x the whole square. Or we can use another formula, byx equal n into sigma dx dy minus sigma dx into sigma dy divided by n into sigma dx square minus sigma dx the whole square. Next is relation between correlation coefficient and regression coefficients. R, which is r is equal to plus or minus root of bxy into byx, where bxy equal r into sigma x by sigma y and byx equal r into sigma y by sigma x. Some properties of regression coefficients are given. First one, bxy is the regression coefficient of y on x and byx is the regression coefficient of x on y. The sign of both regression coefficients will be the same, that is, both will be positive or both will be negative. Product of the regression coefficients is the square of correlation coefficient, that is, r is equal to bxy into byx. When there is perfect correlation, byx and bxy are reciprocals of each other. Last point, both the regression coefficients will not be greater than 1. That is, one of them can be greater than 1 or both can be less than 1. Thank you.